In this video, we're going to talk about a technique called U Substitution. And I know that some of you are a little disappointed that we're done with derivatives and especially done with the chain rule, but you're in luck because U Substitution is basically the chain rule for antiderivatives. In this technique, we're going to be replacing a function with U so that it's much easier to find the antiderivative. Here's the definition of U substitution. It says the antiderivative of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. And this should look very familiar to you. This is exactly the reverse power rule, except in that rule it said x to the n dx. In this rule it just says u to the n du. And we're going to do a few examples to help you understand how to use U substitution. So let's say you needed to take the antiderivative of x minus 4 to the 10th power dx. Well, you could expand out this function and multiply this out, x minus 4 times itself 10 times. That would take a really long time. Instead, you can use U substitution to take the antiderivative and save yourself a lot of time. There's 4 steps that you need to follow. The first step is to decide what u is and what du is. In this problem, I'll just tell you. We'll set u equal to x minus 4. Then we need to take the derivative of both sides of this with respect to x. So we'll say u is equal to x minus 4. Then we'll take the derivative of each side with respect to x. And we'll get this. On the left side, we'll get du over dx. And on the right side, the derivative of this, x minus 4, is just 1. We need to do one more thing. We need to separate du and dx. So we'll multiply each side by dx here. Get a different color. We'll multiply each side by dx. And we'll get this. We'll get du is equal to 1 dx, or just dx. So this was a lot of work, and it's not really clear why I'm doing this yet. But stay with me. After we do enough examples, I think this will make a lot of sense to you. So we have these two things. We know u is equal to x minus 4, and we know that du is equal to dx. So our second step is to actually substitute this back in to the original problem. So instead of x minus 4 to the 10th, we'll have u to the 10th power. And instead of dx, we'll have du. Because we said u is equal to x minus 4, and dx is equal to du. Our third step is to take the antiderivative. So we'll take the antiderivative. That's going to be u to the 11th power over 11 plus c. And our final step is to just substitute back in for u. That's x minus 4 to the 11th power over 11 plus c. Let's look at another example. We'll take the antiderivative of 10x times 5x squared minus 3 to the 6th power with respect to x. And once again, you could multiply this whole thing out and take the antiderivative, but that's just going to be very time consuming, so we'd rather use U substitution here. In our first step, we need to figure out what u is and what du is. And for a little while, it's a little bit of guesswork, but can you see a function and its derivative in the same problem? What if you said u was 5x squared minus 3? Then think about the derivative of that function. The derivative of u with respect to x would be 10x, and this minus 3 goes away. So that seems to work. It makes sense to place u as 5x squared minus 3, because here's u. And then the derivative of that is 10x, which we also see here. The only thing we don't have is this dx, but we need to do one more step and move the dx to the other side by multiplying both sides by dx. Now we've accounted for everything in the problem. We've accounted for 5x squared minus 3, this 10x, and this dx. In our second step, we will substitute these back into the problem. We'll substitute this back in, and we have u to the 6th power, and instead of this 10x dx, we're going to type in du. So we have u, 5x squared minus 3, and then 10x dx, we said that's du. So altogether, we have u to the 6th power and du. We took the 10x and the dx and put them together and just combined them here in the du, even though they were separated. Step 3 is we'll integrate. We'll get u to the 7th power over 7 plus c. That's just using the reverse power rule. And our last step is to place back in what u was. So we have 5x squared minus 3 to the 7th power over 7 plus c. Let's try another example. We want the antiderivative of 2x times square root x minus 5 dx. And we could try to multiply this all together, but it'd be very difficult since this is a square root. So we're going to try U substitution, and maybe that will work. So let's try to think that u should be x squared minus 5. And this is a little bit of guesswork. We're hoping we can find u be something, take the derivative of that, and then that will also be here in the problem. So if u is x minus 5, then du dx, or the derivative of u, would be 2x. Of course, we need to move dx to the other side. So we have du is equal to 2x dx. So let's look back at the problem. Do we have everything? We have x squared minus 5, and we have 2x dx. All of that stuff is here. So it looks like choosing x squared minus 5 was the correct choice for u. So that was our first step, was defining u and du. In the second step, we'll rewrite the problem just using u. So we have the square root, that's the same, of u instead of x squared minus 5. And then instead of 2x dx, we know that 2x dx is equal to du. So we've replaced everything in this problem with u and du. In the next step, we'll take the antiderivative, but before we do that, of course, we need to rewrite this as the square root, or sorry, not as the square root, but as u to the 1/2 power du, because we want to just use the reverse power rule here. We'll take the antiderivative of this, that's u to the 3/2 power over 3/2 plus c. We'll rewrite this as 2/3 u to the 3/2 power plus c. And our last step will be just substitute in for u what we knew u to be from the beginning. That's 2/3 x squared minus 5 to the 3/2 power plus c. And we're finished with this one. Let's look at one more example. We want to take the antiderivative of 3 times sine of 3x minus 1 dx. This could be a good place to use u substitution, so let's try it out. Let's try to figure out what u is and then its derivative. If we can find u and its derivative in the same problem, then we can use u substitution. So let's try saying u is 3x minus 1. Then we'll take the derivative of this function with respect to x. That's going to be 3. Rearrange this a little bit to be 3 dx. Look back at the problem. We see 3x minus 1, and we see 3 dx. So it looks like we can use u substitution here. This sign is still going to be here after we rewrite the problem, so let's do that now. Our next step is to rewrite as sine of u, and the 3 and dx are now called du. So we've changed this problem to be sine of u du. Now we'll take the antiderivative of this, take the antiderivative, and the antiderivative of sine of a function is negative cosine u plus c. And our last step will just be to substitute u back into the problem. So we have negative cosine 3x minus 1 plus c. And we've taken our antiderivative.